Hello and good afternoon. I hope you are all well. This afternoon, we're doing our quick question, practical webinar, and we're going to be looking at the test tube reactions 4 and 7, which means we've only got one practical webinar, one practical that we've not looked at yet, which is number 12. It's nearly 4 o'clock. It's the 2nd of June. And I'm just going to give everyone a couple of minutes just to get logged in and see what we've got going on. If you want to come along and start in the chat room, we are in Dr. Clay's webinar chat. Come along to Dr. Clay's alevelchemistry.com quick question, and I look forward to seeing you there. Okay, so it's 4 o'clock. Like I say, we've just gone live. I'm going to give a couple more minutes and then we'll be starting this afternoon's webinar on test tube reactions. Importantly, we're going to be looking at the group 2 ammonium ions and the anion testing, and then we'll also have a quick look at the transition metals. As I say, if you've got any questions, do come along to the website. Today's session is completely open to all users. If you go along to our Dr. Clay's quick question site, it's in the webinar section here, quick question. You can find links to joining the revision site. You'll also find the actual live stream here. You can click on it through here. And we've got our live chat at the bottom of this page. Do come along and ask your questions here. We haven't got the YouTube chat. It's much easier if you use this blue questions, because I can hear it pop, rather than using the side chat that we get over here. So just a reminder, please, if you're using the chat window, come along to Dr. Clay's A-Level Chemistry quick question, and then use the chat, because I get a little pop like so when the blue chat comes up. There's no sound when this chat window on the side. So I'm not going to be using the chat window here on the right hand side. I'm going to keep that closed. However, I will be online for a little while afterwards. If you've got any questions, feel free to, if you double click on my name there, or if I was to click on anyone else's name here, I'll get a private chat window. Feel free to send me a private chat. I'm just not going to be able to get back to you if you've got any questions until after the live session. Okay, it looks like we've got plenty of people coming along. Once again, come along to drclays-alevelchemistry.com/quick question, and we can pick up the login. Here we go. Do I need to log in? Anon 1915. Not for this session today. Okay, so not for this session. You don't need to log in. You can just ask an anonymous question. That's not a problem. If, however, you would like to access the resources from our live webinars that we do, which are the longer webinars on a Monday and Thursday, you do need to sign up to the website, and you'll find heaps of our past exam resources here. We've been through lots of revision webinars. With each of the webinars, of course, you get access to the webinar. There's also, in this particular instance, the mark schemes, the question papers, and any of the OneNote files that are associated with it. And feel free to contact me, leave a reply anywhere other question places throughout the website. And let's see what we got. We got a quick question. Are you going to go through practicals involving test tube reactions? 1915. What if you look up here, you'll find heaps of required practical test tube reactions here. I'll open these up. There you go, and you'll find in that we got loads of past paper questions here on test tube type reactions. On this session, I'm simply going to go through the key points, and the answer to that I will put up at the end of today's practicals. The two required practicals that we're looking at today are numbers 4 and 11. and on 375, before we get going, the exam board that we are on and that I concentrate on, all the past exam questions that we're talking about today are from the exam board AQA. Obviously, the chemistry is similar across your exam boards, but all of the past paper questions and the detail are referenced to the AQA exam board. Do feel free to have a look around the site, and do please contact me at the end of the session. Okay, here we are, stumbling along now. It's nearly 4:05, and I will get started in just a moment. Again, today's webinar, test tube reactions, which is required. Sorry, that says 4 and 7. This is actually required practicals 4 and 11, as it states at the top page here. We've been looking at all the required practicals in this session. We've already done 1, 2, 3. We've looked at the organic practicals here, 5 and 6 and 10. We've looked at 7 measuring rates of reaction. We've done 8, which is measuring EMF. We've done investigating how pH changes. So today our key points are going to be the test tube reactions and the test tube reactions here, which is our transition metal work. Okay, on Wednesday we will look at the final section here, which is thin layer chromatography, which will complete all of the work necessary there for the required practical element. Of course, you could be asked about a heap of practicals, but those are the sorts of things that you might be asked to recall, identify, maybe plan a practical, so on and so forth. Okay, let's get going then. Let's see, I think we're good to go. Just as a point out, I can see someone here has left me a red message. I'm not going to look at that until the end of the session. I promise I will get back to you, whoever's left that message, later on, once we've completed the webinar session. If you've got any questions, once again, come along to quick question page, which you can find by going to Dr. Clay's alevelchemistry.com. Quick question is the page that you want to go to. And then you'll be able to ask your question there in the blue chat screen, which I'll answer as we go through the session. All right, let's get going then. And if you want to get hold of any of the past paper questions, you'll also be able to get them just there from that page. All right. So let's quickly go and have a look at the key points then for our test tube reactions. The first here are from essentially your AS level, your year 1 part of the course, because this is required practicals number 2. These were the ones that you were asked to know about, are from group 2. How to identify group 2 elements. These are, of course, metals and therefore cations, and also the ammonium, which is NH4+. So these are the cations that you need to know about. There are 2 ways, essentially, of testing for the group 2 metal cations. Now, the first isn't really a test tube reaction. This way of doing it is using a flame test, and it would identify each of the following group 2 elements. In order to do the flame test, of course, you might remember from maybe your GCSEs, you're going to dip nichrome wire in hydrochloric acid. Okay, and then you're going to essentially, once you've done that, you're going to heat the wire, then dip into either a solution or sample, and then finally you're going to place a sample in a roaring flame. Now, that is one way of identifying then, because each of your metals, that's calcium, strontium and barium, these are group 2 metals, will give you a different color as follows: brick red, red and pale green. However, to be quite honest with you, that's not a very good test tube reaction. I would suggest it's a flame test reaction, nothing really that you can do in a test tube. The other way you can do this is by looking at the solubility here of the hydroxide. I think did I include a table into this? No, I didn't. Okay, so we can look at here at the solubility of the hydroxides and the sulfates. So if I was to draw here a table, we got, let's just make sure we get this correct. We're going to have magnesium here. We've got calcium, strontium, and barium. Basically, are calcium, strontium, and barium. These are our group 2s, and I'll just check our question here. Okay. These are, of course, group 2s. There we go. Now, the solubility here of the hydroxide as we go down the group, or okay, let's go. So as we go down, the solubility increases. Okay, and the solubility here for the sulfates increases in the other directions. So in other words, if we did a test tube reaction, if we took the metal 2+ ion and added a few drops of OH minus, okay, and then we would form, certainly for the magnesium, we would form a white precipitate. Okay, for the hydroxide, I'm going to put the hydroxide over here because it is completely insoluble. The calcium ions are are sparingly soluble, and then the strontium becomes soluble, and the barium is soluble for hydroxide. So strontium hydroxide and barium hydroxide are both soluble, and therefore these form colorless solutions. There's the calcium hydroxide here forms a white precipitate again, indicating that you would have the calcium hydroxide. The complete opposite is true for your sulfates. So I'm not going to write that out again, but if you had your sulfates, this whole process would be completely reversed. So at the bottom here, you would have white precipitate, and I'm just going to put PPT for these bottom two, and you would have a colorless solution for these top ones, because the solubility here of the magnesium calcium is greater for the sulfates. All right, so there's 2 ways that we can do some cation testings for the group 2. So I'm just WAG1G. Okay, thank you very much for that, Brill. Okay, no other questions at the moment. We'll move on and have a look at testing for ammonium ions. Okay, so ammonium ions, the test for ammonium ions is quite simple, and it's based on some of the chemistry of ammonia that hopefully you are aware of from your acid-base reaction. So ammonium, we know, well, you might know it the other way around. This is essentially the reverse of when ammonia, so NH3, reacts with water, because ammonia, okay, is basic. It accepts a proton from the water and it goes to form ammonium and hydroxide ions. And what that means, because we've got a reversible, we are oxide solution, you can shift the concentration here minus. What that would do is shift the equilibrium to the right-hand side of this particular equation, which would generate ammonia gas. So what we get off here, we would generate NH3 gas. Now, NH3 gas isn't green. I'm just doing it in green to show it's different. The thing about that is if it's alkaline, and what happens is the equilibrium goes back in the other direction because we get the ammonia dissolves into the red litmus paper to turn blue. Okay, so that there is our test for ammonium, and those are the two key tests that they want us to know about group 2s and ammonium ions. Okay, the En are also required. So these are the negative ions that we're interested in, using silver nitrate, AgNO3, and what that does is it produces silver ions in solution for us. The first thing that we always want to do, though, is we wish to acidify that solution in order to get rid of any carbonate in the solution. So the first thing here is to add some sort of acid in order to remove any unwanted carbonate ions, and that would, because you don't want to form something like silver carbonate. Have is a formation of a precipitate, so we can form with each of the halides except for fluoride. So AgAQ plus F minus, essentially there is no reaction and it stays in solution. But for all the others, Ag plus Cl minus, so these are half equations. Here we get Ag, oh, sorry, they're not half equations, they're ionic equations. We get the formation here. I'm not putting in the state symbols, but in each of these cases, the formation of AgCl, AgBr, and AgI, these ionic equations here, forming silver chloride, silver bromide, silver iodide. These are all solids from solution, so they form a precipitate. Now, as we go down, you should have seen before, hopefully in some of the chemistry that you've done, is that as you go down, these get darker. And so as we go down, we go from white to cream to yellow precipitate. Now, these are not so obvious, and certainly the cream and yellow are really quite difficult to distinguish between. So the further test to identify which halide we've got is we can add ammonia. So once we form this precipitate, we can add NH3AQ, and we've got a few different things. The chloride ions, they redissolve in dilute ammonia. Okay, so we redissolve and we form a colorless solution. The bromide ion, well, that dissolves in concentrated ammonia, NH3, and that precipitates in concentrated ammonia, so therefore we end up with a colorless solution. And the iodide, well, there is no reaction with the iodide, and therefore if we get to distinguish between silver bromide and silver iodide, we can simply add concentrated ammonia. If it dissolves, then we know we've got silver bromide, and if it doesn't, then we know we've got silver iodide. Okay. The next one then, before we move on to the penultimate here, sulfates and hydroxide. In fact, we've already looked at this argument. So here's our table from before, the group 2 elements with the hydroxides. We need to know that the sulfates get more soluble as we go down the group. And that's because magnesium hydroxide ions are of a similar size, and therefore there's a stronger ionic lattice and therefore less likely to be broken down by water. And these get more soluble as we go down the group. The inverse is seen for the sulfates. Again, barium is quite a large ion. Sulfate is certainly a very large anion. and therefore when they are of an equivalent size, we get the least soluble, which is barium 2 plus, and the sulfate ion. So here, the ionic equation, one that they require us to know for sure, is the barium 2 plus SO4 2 minus AQ, going to give us barium sulfate, which is forms a white precipitate. Remember, if we form any solid in a reaction, we describe that as forming a precipitate with a color. If we observe a precipitate that dissolves, we say it redissolves into a solution, all right, depending, and then we might give it a color. So how do we do the barium sulfate test, which is the one that we're interested in? So we use acidified barium chloride. So again, BaCl2. So a suitable acid would probably be HCl in this particular instance. And then you would add that to your unknown ions. If you got sulfate ions present, then we would form the barium sulfate as the white precipitate. Barium sulfate, completely insoluble. Therefore, it's often also used in X-rays, in medicinal use, for barium meals, to basically to show up in X-rays any issues in the digestive system, because it will pass straight through. The final anion then that we'll look at here from the AS, from the practical 4, is the carbonate anion, and we can do that with our classic carbon dioxide test. So if we got a carbonate in solution, if we add some acid, it doesn't really matter which acid we add. Of course, if we're being strict, we should use some state symbols here, and we're going to form carbon dioxide here, which is a gas, plus H2O, which is a liquid. Here, if you bubble that CO2 through lime water being calcium oxide, then with a reaction with calcium oxide plus CO2 gives you what you know to be calcium carbonate, which is a white solid, calcium carbonate being chalk, like the White Cliffs of Dover, and that's why we get a milky white solution. Calcium oxide also reacts with things like sulfates and silicates. This is a neutralization reaction, because the metal oxide is a base and the non-metal oxide is an acid, and therefore we are neutralizing the solution. I'm just going to pause there and see if we've got any questions about practicals 4 and 11. Okay, apologies, I should have said any questions about practical 4. So key practicals we need to know about, they are group 2s and the anion test then. The required practical number 11 then, which we're going to move on to, is our metal aqueous ions, and here we go. So there are some key things that we need to know about. I've identified here the key process as to what we do. So you're going to measure out small samples of the unknown metal ion into solution into some test tubes, and then importantly, the key words that we're using here, okay, is you're going to add sodium hydroxide solution. What we do is we do this dropwise, okay, using a dropping pipette, and record any changes. The sort of recording of changes that we should be able to write down forms a colored precipitate. Now, they're looking for the use of the word precipitate. Colored precipitate simply means a solid. Obviously, you need to give the correct color. Or we might say it redissolves to form a colored solution. All right. Or there may be a solution changes color, changes to a colored solution, And once again, we're just going to replace the word there, coloured, with whatever colour it is. Okay, or the other thing we might describe is there's no visible change. There is, that's when we get nothing appears to be happening. And the final description is if we get bubbles forming, and then we might describe this as effervescence. Okay, so effervescence means the formation of bubbles, or we might describe it as fizzing. All right, then again, the addition here. So to the first test tube, we add in sodium hydroxide solution dropwise. Then the second solution, we add, the second test tube, you add ammonia solution. Again, dropwise. And then to the third solution, you're going to add some carbonate, sodium carbonate, once again, dropwise. Once you've added them dropwise and noted any changes, then you may add more sodium hydroxide. Oops, I didn't mean to actually scribble that out there. I meant to highlight. You may add more sodium hydroxide solution until it's in excess, is the word. So excess is more sodium hydroxide than is required. And we would do the same as well with ammonia. Now, ammonia, quite often, if you've actually done this, rather than using dilute ammonia to excess, often what you end up doing is you keep adding ammonia, but actually you tend to start using concentrated ammonia. So that is the steps you would need to do in order to identify the samples. Then from there, you need to be able to recall each of these scenarios. This is metal work. If you've not come across this, do check out my videos on transition metal. It's played in a A2 level section on my website. If not, please feel free. They are for my YouTube channel. Here we are. You need to be able to know the following about copper, that it forms a blue precipitate on the addition of hydroxide or dropwise of ammonia. There's no change when added to excess, and then there is a deep blue solution when excess ammonia is added, and we get a ligand substitution reaction if we got sodium carbonate. Iron 2+, green solution to green precipitate with, here we got an acid-base reaction occurring. There's no change with the addition of excess OH-, and that's because neither of these are strong enough acids in order for there to be a reaction. There's no change again with excess ammonia, and we get iron carbonate, which is a green precipitate if we add sodium carbonate. The thing to note here is that at the top of that test tube, there may be, so the green precipitate may turn brown at the top of the test tube carefully, and that's because you're getting oxidation of the iron 2+ to iron 3+. So what that does mean is when you're practically doing this reaction, you need to be careful that you don't do too much shaking, and that you really do it dropwise. Aluminium is of course not a transition metal, therefore there's no D to D transitions, and therefore we form white precipitates. We get a white precipitate because it's an acid-base reaction. Further react with OH-. There's no change with the excess ammonia, and here we get bubbles or effervescence or fizzing. We here because these are stronger acids than the Fe2+, or the copper 2+. So the Mn2+ and 2+. The final one, Fe. Here we got with the addition of excess hydroxide to dropwise, we end up forming no change with the ammonia, and then we get brown precipitate and bubbles forming. Okay. It's now nearly half past. We'll just have a quick look at a couple of the past exam questions that we got on the site, and then in about 5 minutes we'll call it a day there. Okay, let's see what we got then. Lots again, I'll put on the past webinar section at the end of this, at the end of the session. These then are questions regarding transition metals. Let's see if we've got any about the AS. Again, transition metals. Again, transition metals. I'm really looking for one on the transition metals again. So let's have a look at question 5. Just to note, this is a reaction about concentrated sulfuric acid. I'm not going to look here at the concentrated sulfuric acid questions, but that's what 5A is looking at. Bromide. Aqueous in any other procedure to prepare a pure sample of silver. What you need to know is that the addition going to acidify to any carbonate. So ideally back, it's probably just the internet. The stream has gone. I'll just pause until the stream is. You can. Okay, thanks, Kate. I'll pause and. And then we should get. So let's just check the. So I'll keep talking for the moment. Please do let me know if this, when this. Maybe my internet connection. Okay. How's my internet? Perhaps you could let me know. Alison, I certainly wouldn't ignore the colours of cobalt, although you're not specifically required about it. I'll finish this question in just a moment. Apologies for that. Okay, David, thanks for the question. Do we have to know about cobalt? You're not specifically asked about cobalt in the so, and certainly in terms of your transition metal chemistry, it's not a requirement from the exam board. However, what you do need to be aware of is the things that they could ask you about cobalt, explaining why it's a color change, and you may need to identify things why you're observing a color change. All right, so if you had let's say a question where they showed you cobalt at the start and at the end, they may explain and you may need to say, you know, that it's a color change because there's been a ligand substitution or a change in oxidation state or a change in ligand, or perhaps even a change in coordination number. Okay, are we back again yet? Okay, I'm not sure if this is going to come back. So I think what I'm going to do is I'm going to pause it there. I will put all of the answers to the... Okay, I'll tell you what. What I'll do is I'll discuss the question there. I'll read it through so you can hear it verbally, just to explain that practical question, because it was quite nice and the sort of thing you might expect to do. And then we'll close down the session. I'll put the answers to all of the exam questions up within the webinar room at the end. All right, okay, so let me just describe the question to you. It says a colorless solution contains a mixture of sodium chloride and sodium bromide. Using aqueous silver nitrate and any other reagents of your choice, develop a procedure to prepare a pure sample of silver bromide from this mixture. Explain each step in the procedure and illustrate your explanations with equations where appropriate. So the first thing to do is to remove any carbonate with an appropriate acid. In this case, probably a NO3 minus acid, so nitric acid. That's going to remove any carbonate because you don't want to add any further chloride. Then what I would do is I would add silver nitrate, because what you're going to do then is you would form both until excess, because you would form silver chloride and silver bromide as a mixture. Then what we saw is if to that I then added dilute ammonia. Okay, I just heard a popped up question. Great, thank you, Kate. That's great. If you added dilute ammonia, your silver bromide will, your silver chloride will redissolve. That will leave you only silver chloride, all right, as a white precipitate. Then what you've got to do is you've got to remove the filter and wash that precipitate. So then I would say I would filter, precipitate. You could do this precipitate. You might do this under vacuum filtration, just to speed it up, but there's no reason to do that, but it will help dry it out. You would then wash with water to make sure you had a clean precipitate, and then I'd leave it to dry. Okay, so those are the steps I would work through in order to get as much of the silver bromide solution as possible. Okay, right. Apologies about the drop in communication there. As I say, what I will do now is I will upload the answers to the two places. I will upload the answers, first of all, to this quick question site, and then I'll also create a webinar page from this. I'll be online for the next 5 to 10 minutes. If you want to ask me any questions in either of the chat rooms, please do so. Once again, thanks a lot for joining me. Monday's webinar at 8:30 p.m. We will be looking at the following. We're going to look at some more complicated nomenclature. We're going to look at skills like graph drawing skills and those expectations from the exam board. And finally, we'll do some multiple choice questions related to the paper one that you'll be doing before long. Thanks a lot for tuning in. Thanks a lot for watching. If you've got any questions, drop me a line in the chat room. Also, if you want to join the site, please do so. And best of luck with the revision. I'll say goodbye for now. Thanks for watching.